Hello students, today we are going to cover Kirchhoff's law, which is applicable to any DC circuit which contains resistors and batteries. Now before going ahead with the topic, if you wish to improve and excel in maths and science subjects, then do check out the courses, micro courses offered by Infinity Learn, and details and link of the website is given in the description. And don't forget to use the coupon code HQ10 to get additional 10% discount. Now let us get back to our topic of Kirchhoff's law. So Kirchhoff basically gave us two laws. One is the junction law and the other one is loop law. Let us check out the laws one by one. The first law is junction law, and the statement of the law is at any junction in a circuit, the sum of currents into the junction must equal the sum of the current leaving the junction. To understand this, let me draw a diagram. Let us say this is a junction. A junction is a point where three or more conductors meet. So let us say I have got two wires with current I1 and I2 coming at this junction, and there are two wires with currents leaving through them, and let us label those currents as I3 and I4. So as per the junction law, the incoming current, which is I1 plus I2, this should be equal to the currents leaving the junction, which is I3 plus I4. Now this law is basically based on the conservation of charge, which says that the amount of charge coming to the junction should be equal to the charge leaving the junction. I hope this law is clear to everyone. Now let us go ahead to the second law. The second law is loop law. Now this loop law is basically applicable when we have closed loops with voltage source and resistors in it. And the statement is the algebraic sum of the increase and decrease in potential differences across various components of the circuit in closed circuit loop must be 0. So I should have a circuit, closed circuit, which has the components. Let us say I have a resistor like this, and then a voltage source, again a voltage source with a resistor, and let us close this loop. Now let us label them. Let us say this battery source is V1, this battery source is having value V2, and the two resistors are R1 and R2. Now since it is a closed loop, we can assume a current I which is flowing through the circuit. Now what the law says is, when we go around the loop, the algebraic sum of increase and decrease in potential differences should be equal to 0. Let us label this loop as A, B, C, D. Okay. And talking about the components, there are only two components that we can see. One is a voltage source and the other one is a resistor. Now the voltage source V has a higher potential denoted by longer terminal, and the shorter terminal is having lower potential, which is denoted by minus sign. Now while writing the equation, please understand, if we trace the loop in this direction, then we are going to take this as minus V. And if the same voltage source is traced in this direction, what we are going to write this as plus V. We will take over here an increase in potential, and in the first case we'll take it as decrease in potential, as the potential is falling from higher to lower. So fall in potential will be taken as negative, and in the second case the rise in potential will be taken as positive. Similarly for resistors, if I have a resistor with value R and a current I is going through it, the voltage drop is given by IR. Now the thing is, if I am tracing it in the direction of the current, I will take it as minus IR, and for the same resistor and same current I, if I am tracing it in the opposite direction opposite to the current, then I'll take it as plus IR. Now what are these things called? These things that we just discussed, these are called as sign convention that is followed while writing the equations. So let us write the equation for this particular loop that we have. So we have loop A, B, C, D, A. So while going from A to B, we are going in the direction of the current. So we will take potential difference across the resistor R1 as IR1 with a minus sign because we are going in the direction of the current. Second, when we are passing through V2, while going from A to B, there is this fall in potential and therefore we will take it as minus V2. From B to C, we don't have any element. While going from C to D, once again we are going in the direction of the current. So we will take potential difference as minus I into R2. And finally, while passing through V1, once again what we find is there is a potential drop from higher potential to lower potential. So we will take this as minus V1. And from D to A, once again we don't have any element. So this all will be equal to 0, and this is how we write equations for loop law. Please remember this sign convention, and this particular law is based on the conservation of energy, which says for a current to flow or for a charge to go around the circuit, energy is supplied by the voltage sources and these energy is consumed by the resistors. I hope you all understood the loop law as well. Thank you everyone.